So we're gonna get into lesson number 3, which is expected value. And basically what this thing is, what are we expecting gain or possible loss if we continually play the game, right? So in any game or situation where there's a gambling or investment of money, there's a chance of winning more money.
Sorry for the interruption. With the owner of the Dodge Journey, reddish burgundy, HPE 984, parked in the student parking side off Webb against fire escape, please come to the office. Once again, HPE 984 Dodge Journey, burgundy color, parked along the exit stairway and the student side. Thank you.
Okay, so okay, let's read that again. So any game or situation where there's a gambling or investing, an amount of money for a chance at winning more money is what the expected value is. So when we're when we're buying a lottery ticket, we are expecting to win, but what is the expected value? Come on in. Expected value. Okay, so how much is the expected value of the winning that we're gonna get? So their expected value of a situation is the average amount of money that you can expect to win each time you play the game or encounter the same situation.
Can I get my test back?
Oh, can I work on this? Maybe tomorrow. We'll work on that tomorrow. Yeah. So there's a small formula that we can use to calculate the expected value. So here you want to write that down on your formula sheet. Okay, make sure you put that on your formula sheet. So expected value, P win. That means this one here tells you what is the chance that we're gonna win, times how much money we're gonna win, minus cost to play. So please note two things related to this formula. This formula is not included in the exam sheet, but if you want it for reference, it should be on the self-made resource. You can add parts to this formula if there are multiple win conditions. So you will see an example later. So a game is played where a 6-sided die is rolled. The cost to play the game is $5. If 1 is rolled, the player wins $25. If anything other than 1 is rolled, the player loses $5 bet. Okay, so calculate the expected value of the game. So this is the formula: expected value, probability of winning, times how much money we will win, minus the cost to play. Right? This cost to play, that would be the amount of money that we have to pay to get a ticket, right? So in this case, there is a 6-sided die. So the possibility that it could land at 1, 2, 3, 4, 5, or 6. That's what the 6-sided die looks like, right? It has 6 sides. So the cost to play is $5. Now it says here, if 1 is rolled, we're gonna win $25. So if we get this one, we're gonna win. Okay? And if we get these, we're gonna lose. So what is the chance that we're gonna win? What is the chance that we're gonna win in here? The chance would be, there's only one possible win, 1 out of 6 possibilities. So 1/6 times, okay, how much are we gonna win if we get the 1? It says here if 1 is rolled, we're gonna win 25 bucks. So we're gonna win 25 bucks. Minus, how much would it cost to play the game? Okay, well, to play the game, we have to buy or pay $5. Okay, so this is where we're actually going to do the substitution. Okay, let's figure that out. 1 divided by 6 times 25. 1 divided by 6 times 25. That's $4.166 repeating, minus $5 of, so we're expected a negative amount. We're expected a negative 0.83. So this is the expected winnings that we're gonna get. Well, because it's a negative value, it's actually a loss. Okay, so this is, so we are expected a loss. Okay, a loss because it's a negative of 83 cents. Okay. So we're gonna actually, it's actually this one here. So the meaning of the expected value, the expected value is negative 0.83, which means a loss. Yeah. Yes, page 12. Page 12. Okay. And then letter C, how much money could we expect to win or lose if we play this 100 times? So if we play this 100 times, so it's going to be negative 0.83 times 100. Okay. So we're going to expect to lose negative $83. Okay. Is that okay? So if we keep playing the game, we're expected to lose $83 from that. It's not a good game because it.
I got a question.
Yeah, for sure. Up or down.
What is the A?
A?
What does the P stand for?
Probability. Yeah. What's the chance of us winning the game?
And that's where the 1 6
Yeah.
comes in.
Yeah, because there's only one ones. Yeah, out of the 6.
And then in brackets it says win.
Win. Yeah. So probability of winning. So that's all of these. What's the chance? The chance of winning is 1
Okay.
out of the 6.
So the P win is the whole
Is
thing,
1 6.
1 6.
Yeah. You got it. Is that okay?
Yeah.
Anything else? Let's take a look at example 2. A school is looking to have a fundraising activity at their school opening barbecue in September. They are going to have a spinner that is split into 10 equal sections. There's a spinner that's split up into 10 equal sections. 2 sections says win, and 8 sections say lose. A person can spin the spinner for $2, and if the spinner lands on a win, the person wins 15 bucks. Okay, so let's see if this is a good game or not for us. Okay, calculate the expected value. So this one here is just a win-lose situation. Okay, so we're going to use the probability of win. What's the chance of winning? Times how much money we're going to, how much money won, minus cost to play. So let's see. If there's a spinner, so what is the chance of winning? So there's 2 that says win, 2 out of 10 spots, right? 2 out of 10, so 2/10 chance of winning. Times how much money are we gonna win? We're gonna win $15. $15. Minus the cost to play. The cost to play is $2. So we have to first pay $2 to be part of a game, and then there's a chance of winning times the amount that we're gonna win. So let's take a look at that one. So 2/10. So 2 divided by 10 times 15. Okay. That's gonna be $3, okay? Minus $2 is 1. So, oh, that's a pretty good game. We're gonna end up with $1, a positive value. Okay, so that means the player is expected to win the game, win $1. So do you think this game is going to help the school raise money? No, right? Because it's gonna help the player, but it's not gonna help the school. So no, because the players are expected to gain $1, which means the school is expected to lose. So the student will gain from this game, but in that case, the school is expected to lose money. Is that okay? Good so far? Let's take a look at example 3. You just bought a raffle ticket for $10, okay. Any individual ticket is 0.1% chance of winning a trip worth $8,000. A ticket also has a 5% chance of winning a $35 grocery store gift card. Calculate the possible winning. Now, in this case, it's winning is split up, right? There are 2 ways you could win. You could win a trip, but we could also win a gift card. So in this particular case, this formula won't work in this case, okay? So what we can do is the revised formula is looking like this. And this formula is on your formula sheet. Did I put it on a formula sheet? It would be on your formula sheet from the provincial exam. So this is the expected value formula. Probability of winning times a gain minus probability of losing times a loss. So expected value. Probability of winning times gain minus probability of losing times loss. Money loss. Okay. So this is what we could do. Okay. So in this particular case, you have some chances, right? Winning, probability of win, probability of loss. Okay. So the first part is winning a trip. So a trip, what's the chance of winning a trip? The chance of winning a trip is 0.1%. So 0.1%. Okay. And what about gift card? Gift card, it's 5%. Okay. So probably I'm gonna get rid of this one first. So if we win by 0.1%, how much are we gonna gain? How much money are we gonna gain? This is the value gained. It says here the trip is worth $8,000. Okay, so this is why it's a little bit different here. If we win the trip, the value is $8,000, but because we paid $10 for the ticket, so it's gonna be 8,000 minus $10 is our gain. Okay. So 8,000 minus $10, that's our gain. So how much did we really gain from this? It's going to be $7,990, right? Because this, we didn't really gain the whole $8,000 because we paid into the game at $10. Now for the gift card, we're gonna win a $35 gift card, but because we had to buy a ticket minus 10, so really we gained 25. And net gain. Okay. Now, if this is winning, we have 5.1% winning. What's the chance of losing? So 5.1% win. What would be the chance of losing? The whole thing is 100%, so that tells us that it's going to be 100% minus 5.1%. That's going to give us 94.9% lose. So if we have 5.1% chance of winning, then there's a bigger chance of 94.9% losing, because winning and losing should add up to 100%. Okay, so here, probability of win is 0.01%, so 0.001 times, we're really gonna gain 7,990. Okay, but here's another chance of winning, 5%. 5%, changing that into a decimal, so 0.05%. 0.05 times how much are we gonna actually gain? We're gonna gain 25 bucks. Okay, so these are all the winnings.
How did you get 0.001?
If this is 0.1%, 0.1%, so percent means per 100,
Oh, yeah,
so
you're
divided by
very
100.
good.
Yeah.
Okay.
And then minus, what's the chance of losing? 94.9%, so 0.949. And how much is, so this is times, and this is a plus. So this is a win and gain, and then this is also win, probability of winning, and then gain. Because this part here are all win, right? These are all winning.
So you're still working on the
Yeah, on the
first
winning
segment.
part, yeah. Yeah. Yeah, we have two ways of winning. We can either win a trip or we can win a gift card. That's why we have two of these. So times, and then plus, and then times, plus. And then minus, now this is the loss, okay? So the chance of losing is 0.949 times losing. So if we don't win, the money that we use to pay for the ticket is gone, right? And that's our loss. So this is a chance of losing. Now if we didn't win anything, our $10 is gone, right? So let's calculate all that piece. We can do it all at once. So 0.001 times 7990 plus 0.05 . Oh, we're expected to lose. So this one here, the expected value of expected loss is 25 cents each time. So what is the expected value if you buy 7 tickets? If you play 7 times. So it would be negative 0.25 times 7. Negative 1.75. Okay. Is that okay? Yeah. This one is a long one. This is on the formula sheet. And the reason why we have to do this is because there are many ways of winning and possible winnings. Is that good? Let's take a look at example 4. Expected value analysis can apply to any situation where there's a potential gain or loss. So business is a common field where there's a kind of analysis is regularly performed. So it says here, it cost $1,000 for Sherry's construction company to bid a construction project due to the time involved in preparing the bid. If Sherry submits a project, there is 1 in 4 chance that she will be awarded the contract. That means winning the contract. If she is awarded the contract, she will be paid $3,000 for the work. Calculate the expected value. So here in this situation, it's just either win or lose situation. Hello? Come on. So it's just a win-lose situation. Okay? Can I talk to you in a second after I'm finished? Thank you. So this is only one, it's a win-lose situation in this case, right? It's not a multiple ways of winning. So it says here, if that's the case, then we can just go use the formula at the front, right? We can just use the formula at the front. So probability of win times money won minus cost. Cost to play or cost to participate in this bidding. Okay. So it costs $1,000 to bid in a project due to the time involved preparing. If Sherry submits a bid on a project, there is a 1 in 4 chance. So that's our probability, 1 in 4 chance. So probability that she will win is 1 out of 4. 1 of 4 chances. Times how much will she actually win? $3,000 minus cost to do the project. So this is the cost for her, $1,000. So 1/4 times 3,000 $750 minus 1,000. So there's an expected loss for her of negative $250. Okay, so she's expected to lose $250. So justify whether, the word justify means to prove and to back up your answer. So justify whether she should continue to bid on the contract of this type based on the expected value. So should she? The answer would be no, right? No, because okay, maybe no, she should not. Should not bid because the expected value is a loss. Okay, so she's expected to lose money. Okay, is that okay? Last but not the least, example 5. Aiko is a traveling salesperson. She drives all around the city every week selling her high-end home theater equipment. Her car costs $260 gas, insurance, and lease payment. So that's the cost to do whatever she does. Each week, there's an 8% chance that she's going to make a sale. There's your probability. Her commission on the sale is worth $32,250. That's what she is expected to get to win. Okay, should she continue doing this selling business? So in this case, it's only a two-way possibility, either winning or losing, right? It's either winning or losing. There's no multiple ways of winning. So expected value is probability of win times how much money won minus cost to play. Okay, whatever cost that she initially puts in. So what is the probability that she's gonna win? Meaning, what's the probability that she's gonna make a sale? It's 8%, right? It's 8%. Every time you see a percent, we change it into a decimal, right? So 8%, so that's 0.08, right? 8% means 8 divided by 100 times how much money she's gonna make. Okay. Her commission is gonna be worth $3,250. That's how much she's gonna get or win if she gets a sale. Minus the cost to play. how much did she put in? She's gonna put in $260. So let's figure that out. 0.08 times 3250 minus 260. Oh no. She's gonna get a $0. Okay. So should she continue doing this selling of home theater thing? Her expected value is 0. So the answer is probably no. She should not, because her expected value is $0. So she's not gonna lose money. She's not expected to lose, but at the same time, she's also not gonna be expected to win or gain money, right? Okay, so I'm gonna stop right there. We have about 20 minutes to try some of these questions, and then yeah, I get those questions. Give those questions a try.